We are talking about trigonometry, and we want to find trigonometric ratios using right triangles. So trig ratios summarized. We have the symbol theta, and that's the name theta, is a variable used to represent the angle measure. And for this instance right now, we will use degrees as the unit measure. So it's important to understand which angle we're talking about, because that's going to change the ratios that we're talking about. So for example, if we're looking at this triangle here, the one thing that's never going to change is where the hypotenuse is located. So here's the right triangle. The thing that's never going to change is the hypotenuse is always opposite the right angle. Now, the other two sides that we talk about adjacent and we talk about opposite. And that changes based on where the angle of reference. So if we're talking about the angle of reference is A, and we give a measurement of theta here, that means that the adjacent side is the side that is touching the angle. So we have the hypotenuse that touches the angle, and we have the adjacent side, or A. Then our remaining side that we have left is we have the opposite side. Now we have the same triangle drawn right here, and we've already talked about this, but the hypotenuse never changes. The hypotenuse is always opposite the 90-degree angle. Now, if we move the angle of reference from A to B, that's going to change where our other ratios are located. So if we put theta here, now the adjacent side is the side that is touching the angle. So we have the hypotenuse is touching the angle, and adjacent is touching the angle, or makes up one of the legs of the angle. And then opposite is the side away. So we can see that depending on if we have a reference of angle B or reference of angle A, our opposite and adjacent change. So theta identifies which angle we're talking about. And then the sign gives us the ratio. So if we're talking about the sign of a function, we're always talking about opposite over hypotenuse. So sine of theta would be opposite over hypotenuse. But sine of theta, where it's at B, that's opposite over hypotenuse. So we can see how that ratio changes. And we can kind of shorten it up. We can say S theta equals O over H. Next we have cosine theta is equal to adjacent over hypotenuse. So if we're talking about cosine of this angle, adjacent divided by hypotenuse. So we're talking about side lengths. Adjacent there is the length of this side, and the hypotenuse is the length of this side. So that's the ratio. We get A over H. And then tangent, and we talked about this in the previous video, but when we're talking about sine and cosine, those are always going to be a fraction or a decimal, because we're always dividing by the hypotenuse, and the hypotenuse is the longest side. So when we take a short side divided by a long side, that's always going to be a fraction or a decimal. Short side divided by a long side, that's always going to be a fraction or decimal. Now, when we're talking about the tangent, now we're talking about opposite over adjacent. And so this could be a fraction or decimal, or it could be a value of 1 something for our degree calculation, when we do our degree calculation. Okay. So to remind us, we have so, ka, toa, and you should write this down, especially early on when you're practicing. You should write this down multiple times. So, ka, toa, because that will help you remember it. Now we have a couple examples to look at and of how things kind of change. In example 2. So here we have the sine of A. So the sine of angle A. So for this example, we always have the hypotenuse is always going to be the same. So 13 is always going to be the hypotenuse. However, adjacent and opposite are going to change depending on which angle of reference we're talking about. So here we have the sine of A. And the sine of A is always, if we look at so we write down our fraction. That's going to be opposite over hypotenuse. Okay, so we can write our fraction down. And these are a ratio. So we're looking at the triangle over here. So the hypotenuse of this triangle is 13. Now, the opposite is going to change based on the angle. So we're talking about the angle A. Which side is opposite from angle A? And that is going to be 12 because 5 is adjacent. So 12 over 13 is the trig ratio. Now we have the cosine of A. So we're still talking about angle A. We're still going to come up with our fraction. And we're going to write the values in. So cosine is adjacent over hypotenuse. So hypotenuse is in the denominator, adjacent is in the numerator, and adjacent to A is going to be number 5, or distance of 5, and the hypotenuse is still 13. Next we have the tangent, and we're going to come up with the tangent ratio. So the tangent ratio is opposite over adjacent. So opposite over adjacent. And when we use this value, opposite is 12 and adjacent is 5. So in this case, we can see that 12 over 13, if we use our calculator, that would give us a decimal. 5 divided by 13, if we use our calculator, that would give us a decimal. 12 over 5, we can see that our numerator is bigger, so we'll get a decimal, but we'll also have a number that is greater than 1 in front. So it's not just going to be a fraction, or between 1 and 0. Now we can look at how the ratios are going to change, because we have the sine of B. Now the sine ratio is still opposite over hypotenuse. That doesn't change. So we're still going to have our opposite over hypotenuse. Now our hypotenuse doesn't change either. That's still 13. But now our opposite, if we're talking about angle B, our opposite, so 12 is adjacent, opposite's the one away from it, so that's 5. Next we have the cosine of B. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. Our hypotenuse doesn't change, that's still 13. But now adjacent to angle B is 12. And so that's our new adjacent for angle B. And then tangent of B is opposite over adjacent. So opposite of angle B is going to be 5. And I guess I wrote this 5 in the wrong color. So opposite over adjacent, so opposite is 5, and adjacent or the side touching is 12. And that's a brief example of the trig ratios.